Alright, next this is O12 notes, graphing slope-intercept form. Your objective, you'll be able to graph an equation giving an equation in slope-intercept form. So, slope-intercept form is y equals mx plus b, where it's a y equals and then m stands for the slope, and b stands for the y-intercept. So in other words, we're going to put the number where the line crosses the y-axis. That number we're going to put there for b. And the slope, just like we talked about before, is rise over run. So we're going to pick 2 points and we do rise over run to find out what the slope is. Alright, so let's take a look at this one. Our directions say, sketch the graph of each line. So our goal here is we have to draw the line of y equals 2x, or 2/3 x, and then plus 0. Now that plus 0, that's my y-intercept, that's my b. We're going to always plot the y-intercept on the y-axis at whatever number they tell us here, so that if there's nothing written out, we do plus 0, so I put a plus 0 there. Then from that point, we're going to do the slope. This is rise over run, so this is up 2 to the right 3. So we go up 2, 1, 2, to the right 3. And that's where our point is. Our 2 points, we now connect them with our straight edge. And we make a line. Now we successfully graphed the line given slope-intercept form. Y equals mx plus b. Let's do another one. Here's problem number 2. Once again, our goal is to graph this line. And it's given y equals negative 1/3 x minus 4. So the first thing I need to do is graph the y-intercept, which is negative 4. So I put a dot at negative 4. Then, this is negative 1/3. I like putting my negatives up top, so I'm going to change it from in the front to up top. So I have down 1, because it's a negative 1. And then to the right 3. 1, 2, 3. And then connect those dots with the straight edge. And I successfully have graphed this given line here of y equals negative 1/3 x minus 4 on the graph. Here's our next problem, problem number 3. We have y equals 6x plus 5. We have to remember that this positive 5 is our y-intercept, so that means we have to plot a coordinate at positive 5. Now this has a slope of 6. Any integer you could put over 1. So 6 is the same thing as 6 over 1. So if we rise 6, oh no, we're off the graph. And we go to the right 1, we're still off the graph. Anytime we go off the graph, this 6 over 1 is the same thing as negative 6 over negative 1, because a negative divided by negative is a positive. So from this blue dot, we could actually go down 6 to the left 1. And that's where we'll find our other coordinate. So if anytime you go off the graph, you could actually do the reverse, put 2 negatives or change both the signs to make it on the graph. So now we successfully graphed the line. That's y equals 6x plus 5. Now obviously if you have a graphing calculator, you could just plug it right into the graphing calculator and you could get your answer. That's nice and easy, just like we were practicing in class too. But if you don't have a graphing calculator, not a big deal, we could do it this way. So our b is negative 2, so we plot a point at negative 2. And then from that point, we're going to go up 1 to the right 3, because that's what the 1/3 means, rise over run. So go up 1 to the right 3. Make a point there, and we connect them. And I draw it always all throughout the graph, so it's nice and pretty. And there's our line. Let's do another one, just to make sure we got this. We have negative 2. That's our b. So we plot a point at negative 2. Rise over run. So we go up 7 and then to the right 4. So numbers can get big a little bit. We connect them up. Like so. And voila, we have slope-intercept form. Let's do this one. Y equals negative 4 fits x plus 4. So we plot a point at positive 4. This negative, I'm going to put it up top. So we have down 4 to the right 5. The reason why we do that, because that's what our slope is, down 4 to the right 5. And then connect those points. And we have our line in slope-intercept form, or given slope-intercept form. So we have y equals 4 fifths x plus 3. This positive 3 is our y-intercept, so we plot a dot right at 3. And it's a rise of 4 and a run of 5. So we rise 4, run of 5, up, we're off the graph. Not a problem, because 4 over 5. We're going to change both these signs. This positive 4 turns into a negative 4, and this positive 5 turns into a negative 5. We're doing that so we could get a second dot on the graph. So we go down 4 to the left 5. We plot that next point, and that's right on the graph. So we connect them with the straight edge. And there you go. Now, there's some special cases. Anytime it's a y equals a number, it's a horizontal line, as seen here in red. It's going to be a horizontal line, a line that goes left and right. And anytime it's an x equals, it's going to be a vertical line. So if I have y equals 3, the line's going to be horizontal, like you see in red. If I have x equals 5, meaning it starts with an x equal, then it's going to be a vertical line going up and down, like you see in blue. Let's practice a couple. So in this case, we have y equals 2. Anytime you have a y equals a number, you're going to draw a horizontal line at that number. I'm going to draw it at y equals 2. I'm going to put it at 2. So that black line is the equation y equals 2. Now let's say I have the equation x equals 7. Well, x equals 7, that means I got to draw a vertical line at 7, which of course, in this case, it's a little bit off the graph. Well, it'll be that black line right there, x equals 7. Or if I said x equals 4, the vertical line will be there at 4. If I had said x equals negative 2, then we'll have a vertical line at negative 2. If I had y equals is that horizontal line. So if I had y equals 6, that means it will be a horizontal line at 6. If I said y equals negative 3, then it'll be a horizontal line at negative 3. Alright, so here's your classwork and your homework. If you have any questions, feel free to email me or come to Extra Help. I'll be happy to help you out. Alright, have yourself a good night.